I guess we'll give AJ a couple of more minutes.
Yeah, and also I messaged Parshva and he got pulled into yet another meeting, so he won't be joining until 1:30.
Okay.
Let me see if AJ is back. All right, AJ's on his way.
Okay. All right. So let's continue with our little example here. I have made a couple of changes during the break, but I mean, we'll cover those. So let's. So basically, here I change it to assume that maybe we want to like arm a timer, right? In the sense, we don't want this execution to like last forever, and so we'd arm the timer, which is typically something you can do behind the scenes in the software, and then when we do, so we perform the function, right? We call this activity sum function here that we talked about. I'm not gonna fully specify that one. And we come back, we have a result, and now we can check to see the result was okay. Let's just assume that you know there's a number coming back. If the number is 0 something, right, then it's not okay. Otherwise, right, we can basically say okay, everything's fine, right? So this is here. I basically went to create a decision node, right? That's the little diamond, and then the tool will kind of the label they'll kind of make it float like that. So which is fine. Right? If it's small, if it's a pretty small label, I usually do the Visio thing. I put it like inside the diamond. There's no big deal either way. So now we have to say okay, so the execution is okay, right? Let's say it's true or false, and so how are we going to model that, right? So if it's let's assume everything's okay. So that would take this path out. Now, if I just do this, right, the tool's going to give me option. It doesn't know. It's not smart enough to know that if I come into a decision logic like that with an object flow, in other words, with what's like in this case a data coming back in, then it has to be an object flow going out, right? Because it's just a pass through, right? The only question is, you're going to go here or you're going to go there. And so, but I see people like come in with data and they do control flow. It's like, well, that doesn't make sense, right? Because you can't change it on the fly like that. This is just doesn't actually do anything, right? It just lets you through one way or the other. So in this case, if I take this path out, right, I would have to still do an object flow because we're passing right that result back into that action. And again, I'm just going to see if I can make this look a little bit better. Maybe coming out of these diamonds and getting the arrows to look good is always a challenge in this tool. I don't know why they make it hard, but they make it hard. And then again, I'll just take off. We already know, right? It's the same result being passed down. There's no need to reconfirm that information. So how do we label a particular path, right? That is, so remember that it's called a guard condition when you come out of a decision logic. So I know a lot of people just put it in a label, but technically what you're supposed to do is go to the constraint. And then this is the guard condition, right? So the guard is like, it's like a railway guard, right? So basically it's you open up the gate or you don't. And so in this case, we would say, we could be explicit, right? Like, say result, because result is some number. So let's say if the result is greater than 0, then we take this path out, right? And then the tool will automatically put these brackets there. because that's part of the specification. That's how it's supposed to look. That's why it's a guard. It's not just a text, but it's a guard. So that has to be met, you know. You could pseudocode it or just put it in English. It doesn't matter. And then if it's something else, then we're going to go this path out. And again, it's still an object flow. Right, so again, the tool will automatically create the pin for us. And we'll just take that label off. Backspace. Oops, that didn't quite work. Let's try it again. F2, backspace, enter. Right, and now so we generate an error report or error message, and it's going to be fed back to the user. So we'll keep it simple. We'll just put an action here. It's going to say read result, right? So the end user or the driver, whatever it is, right? The driver is going to read the result of the command execution. Read results. Right, so again, so it's actually passing some kind of a message here. So we could again do a object flow, right? Because we are passing something. Again, here we'll just make it message, right? Will be of type string again, right? To be, if we want to make it fully complete, we'll say we're passing some kind of text message back, right? Again, here we don't need to do anything. And here I'm just going to use the read result, right? One way or the other, I'm going to use the result. Well, if it's an error, I guess technically, the user could retry, right? But we'll keep it simple in this example. And so here again, I'm going to think how we would do that. Okay, so here's a good example of having to use a merge node, right? Because if I connect this thing here, then it means that I know I'm going to go this path or that path, never both, right? So if I connect it to here, that would be a mistake because that would hang my flow. So here's where we're going to put in a merge node, for example. I could put two different actions here, right? But I wanted to show you the example of a merge node. So we're going to go here into the merge node and see if I can align that a little bit better. Right, the node itself doesn't really need a text, because again we can kind of tell, right, that it's receiving multiple. It's going to receive multiple in. So we do an object flow here. Again, in this case, it would be the same thing, right? You can kind of pick up message from here, the message here, right? And then of course it has to be the exact same type, or at least a compatible type, right, to be consistent. So we'll use string again, right? And so that's kind of how we can make it look okay. And then for here, right, again, we're going to go another object flow, right? Because we keep passing the thing down. So object flow here, right, there we are. Okay, and then let's say at this point, oops, regardless of whether it's an error or not, right, we're out of there. So we do like final, right? So where is final? What do they call it? Flow final. Flow final. Oh, there it is. Flow final, right? And this may be a control flow. We're not passing anything down anymore, right? Oh, no, sorry. Activity final. My mistake. Right, delete that. I just do it that way. It's easier sometimes. Flow final, no, activity final. Like the bullseye is the thing we're looking for. It's like we're completely done. We're out of here. We're done. Okay. So control flow. Now let's make this a little bit more realistic, right? What if, okay, so we arm a timer just because we don't, if the system hangs or something like that, we want to be able to get out of there. So let's say that we arm like a 60-second timer, right? So now we need something in a model that says, well, okay, so when that time, if the timer goes off, if we reach this endpoint without ever the timer going off, then we know we're good, right? Everything's fine. But if not, then we need to be able to model that. So that's where you're going to see special kinds of actions. You could do that with an accept event, because there's multiple kinds. I'll show that later. There's also like a dedicated, well, just purely graphically, right? There's something called an accept timer event. So we're going to put that on the side because you cannot like control, right? You don't control when that timer goes off, right? That happens, let's say, automatically. I'm just going to change the label here to say, let's say it's like a 60-second timer, right? The other thing I do when I model stuff like that is, okay, I want to make sure that when somebody looks at this, that they understand that this 60-second timer was basically the result, the fact that this event could happen, right, was the result of this command here. So, you should not use control flow because we can not really passing control to that event handler. Otherwise, it would execute right away, right? That's not the intent. And it's also not an object flow, right? It's actually neither of these things. But what I typically do then is I'll use like the quick linker, for example, and I'll put a dependency there, right? So dependency is totally neutral, but it's just something graphically that you add into your model to say, hey, this timer event for it to happen is dependent on, right, the execution of this, because you have to arm the time before the timer can go off. You have to arm it. If you don't do something like that, then the question is, well, okay, well, where is this? Is it this timer? Is there some other timer floating around? Is this like a system timer, like a global timer? What kind of a timer? So you're making it explicit that, yeah, by the way, this is the timer that I armed here. Right? And then at this point, so should the event happen, right, we have to take some action. So let's say that I'm going to put an action here. I don't like the fact that you can't move this label. So that is one of the reasons I generally don't use this particular syntax. As a matter of fact, the way I would do it is I would just use a generic accept event, which is not just timer. I will talk about that a little bit later. There's different kinds of accept event timers that you can use. So let's remember. Yeah, here's a trigger. Sometimes the tool takes a second or two before it shows you the trigger. So we'll put the trigger. Well, the name doesn't really. We already have a name for. Or no, we could name it. We'll put the same 60-second timer in there. The type, right, and we'll talk about these other kinds, is going to be time. So it's a timer event that we're looking for. For that, I mean, you could actually click on a specification and you could put again 60 seconds. I mean, the tool just puts a text box there, which is actually, there are some formal ways in which you can specify time values. They don't actually do that. So in this case, I'm leaving that off. I am saving that, as we said, will actually go in to the database as a trigger, right, for that particular event. And then here, I'm just going to, because the tool does not automatically copy over that text, so I'll just copy it over, right? And then we'll just do that instead. Right? Just because this one is like graphically, I mean, I know it looks like an hourglass and it makes it easier to see it in one way, but I just don't like the fact that the text can't be moved. So in this case, right, we would just take some action here. We're going to do control flow. Let's just say that would prepare some error message to the user, right? So let's say report timeout back to the user. Okay, so now same thing, right? We're going to send that message. So here that's going to be another object, right? Because we're passing a message back to the user. Again, right, that will be, I just say message, right? And I would make it a string. I'm just going to save some time and not go to the same steps again, because you already seen those, right? And then the user, right, same thing, right? They could decide to retry at this point. In that case, they would go. Let's see if I can. That's one disadvantage of putting the label in the middle. It's sometimes harder to select that diamond, right? And in that case, here I would go back to, let's say, well, in this case, I just go back here because let's assume it's the exact same command, right? The user wants to retry, so we'll do a control flow. And then this is another case where you do need to change, right, the line style, because otherwise you never get it right. So we'll do it like this, and then like this, right? And if the answer is no, then we can just simply connect to this guy here, right? Control flow is like we're out of here, right? And again, same thing. Right click on the command on the line style, orthogonal. Right? Let's actually break that line and do something. Oops, something like that, right? So it's a little bit just to make it a little bit more realistic, right? In terms of what we're actually doing here. You do have the little jumps. Well, sometimes the tool puts little jumps, like in this case, they took the little jump. They had it there for a second and then they took it away. Not sure why. But right, it's supposed to jump over the line here. So that makes sense, generally speaking, right? So we gotta have quite a bit of functionality. We can add some more things going down the line, but we have the basics, right? We have commands, we have control flows, We have how to pass in data. We have the concept of an event handler sitting on the side that can, so basically it's like a race condition, right? The 60-second timer, this is going to execute if this takes longer than 60 seconds. But if not, then we know that we're either going to go out, right, boom, and so the timer, once you're out of here, right, the timer is irrelevant, doesn't, right, can't do anything anymore. Yes, no?
What is the name of the diamond block?
That is called a decision. So in this language, they call it a decision. And UML is SML, right? Yeah. So you have decision.
Thank you.
The merge. This is the merge guy. Notice, right? They look exactly the same. I mean, I made these guys a little bit bigger, but graphically you can't tell the difference. But logically, right? The merge is going to be multiple coming in, one going out, and when you do these, is always like one going in, right, and then multiple, at least two, right. And if you have like 5 or 6, it becomes really tricky because the tool only allows us to attach to the corners. So you have one coming in and you have 3 corners. After that, you have to like join the lines and make it go out. It's not as easy as it should be, but most of the time you do 2 or 3, and you don't have like a switch statement, right, where you can have 20 possible outcomes. All right, so this is kind of like how you're going to model that, right? So that also the tool functionality. So let's take a look. It's kind of similar, right, to this example. We did everything that was in there. So object nodes, we already talked about, right? It could be object, could be data, could be fuel, could be right anything in SysML. And so these are the 2 different ways to model it. Occasionally you may see it like that, but this is kind of what we just did, right? It's kind of the common way. And you notice the tool will help you, right? You just have 2 actions, you draw an object flow, the tool automatically creates the pins. They don't always do it, by the way. There are a few cases where they sometimes forget to do it. In which case, if they forget to give you the action pin automatically, there is action pin here. You can just drag it onto the action, or you can also right click on the action and say, give me, because it is a child, right? Is the input and the output of that action, and just add an action pin in case they forget to do it automatically for you. So classifying, right, objects, it's the same thing with the pin, right? Whether you created this kind of an object or, right, you do a control L, you can do a control L on a pin, right? You saw me do that a couple of times here, where I just, made it like a real number here, right, from the library, from the top library. Sometimes you just, I mean, you again, my same comments that, when you have the pin, remember they do give you the option to just use their built-in strings, but it's you don't have control over this list, right? So it's better to pick value types that you have full control over. So that's that. Multiplicity, yeah. On the object side, same thing on the pins actually, right? Or even on the parameters that I was doing here. Remember that some function where we call this guy, if we look it up in the browser, or actually I have it, I think I put, yeah, see, right, here's where we created that, right? I just left it undefined multiplicity wise, because again, it's like the common, right? If you don't say anything, it has to be a 1. But what if you're passing in an array, which is not the case here, but it could be 0 to 1 if it's optional. It could be 1 to many. It could be an unlimited array of values, or if you're always passing 2, you would do something like this, right? And you would see 2 here, and then if we go into our command, right, you see 2 here. So you can set multiplicities to indicate, right, that you're not just passing in a single value. If you make something optional, in a sense, if I set 0 to 1 here, right, that means that this, when the control happens, so when this thing is done, right, and you say, okay, it's a 0 to 1, it should be 0 to 1 on both ends logically. That would just mean that, okay, if you don't have anything, I'm not passing anything back, you still, the guy takes control, right? But if I say, if I put a 1 here, for example, and a 0 to 1 here, and I'm not passing anything back, then we get stuck there forever. Right? So there's like inconsistencies that that you can get into that way. You wouldn't notice that until you like try to execute this, right, or simulate it. Well, even on their simulation, they don't even look at multiplicities, which is pretty poor. But logically, it still wouldn't make sense, right? You have multiplicity. You can also set the state, but that's rarely done. So creating action pins, yeah. So this would be if you have to do it manually, if the tool doesn't do it for you, right? You can, or just use it from the toolbox. And classifying, right? Control L or right click. I think on the pins, there's also a property sheet. Let's double check that. So if I just click on a pin, yeah, see there's a pin property sheet, right? So you could basically set it here as well. And then input or output, the tool, when they automatically generate them, they're smart enough to know that this is an input. They also automatically generated this guy. They're smart enough to put it in output. Is it a big deal? Probably not, unless you try to execute it or something like that. But ideally, if you do it manually, so you're supposed to think about it, right? Say, okay, this is an input or an output. So here's these multiplicities, right? First in, first out. If you have ordered, right? If you have like collections, right? Then you can say it's an ordered list, or it's a bag versus a set, things like that. But the key thing that you're going to change is going to be the data type, right? The type that it represents, and then whether it's an input or an output. So activity parameters, right, is basically just the inputs and outputs of an entire activity, right? I showed you examples of that, right? So here's an example also, right? There's an input parameter and output parameter, right? Text to XML conversion, you pass in the string. They're both strings, right? But this is just a text, and then this is going to come out as an XML stream, for example. So activity parameter, same thing as an action, as a pin, right? And I noticed that when I dragged this sum function in here, which has, right, an input and an output parameter, the tool automatically, they don't automatically visualize it, but when they if you look at the features window, right, they create the pins. So in other words, these are not parameters, these are pins. So the tool takes care of that. So they look at how many parameters you have, and they automatically create a pin for each of those parameters. But whether you visualize them, you still have to decide, right, to come in here and say, I want to see it, I want to see it. So again, the pin itself, right? Technically, if your pin was automatically created from like a call like this, I should not be allowed. I don't have the tool. Well, see, okay, so I cannot. This is grayed out, right? So I cannot change the data type, and technically, yeah, this is grayed out as well, right? Which makes sense because this is just the pin that corresponds to the parameter. If I needed to change the data type from real to maybe just an integer or something like that, I would have to change it here on the parameter. Right, so they kind of protect, because they have to keep these things in sync essentially. So visualizing, right, synchronize. You can do a synchronize. I think most of the time you notice, right, when I visualize this activity that I was calling, the tool automatically, I didn't have to do anything, right? But let's say that you decide at some point, well, let me add a third parameter, right? So at that point you could do a synchronize, and then the tool will add, will refresh the diagram and add the missing parameter. So you can sometimes use synchronize. Most of the time they do it automatically. So again, this is kind of similar to what we already done. Okay, so this would be an example of a fork. Right, so graphically speaking, just going to look like that. I mean, it's one of those elements that if you have, here's where fork and join. Right, and the tool is using the exact same element under the covers, which which is incorrect from the spec perspective. But and so you have horizontal. Basically, is like, okay, if you're going down, then you pick horizontal, right? If I weren't going down, I'll pick vertical. And then you cannot make this wider, right? This is just how the spec wants it to look, but you can of course make it larger, right? So I mean, this is kind of a silly example here, but I could go into here, let's say with a control flow. Right, now same thing, if you have control flow coming in to the fork, right, then you should have control flow going out. If it's an object flow, should it be object flow? I think there's some rules about doing a combination of the two, but I'll have to look again how that actually works. And so from here, then let's just say that we have two more actions. Right, let's keep it simple. Action with control flow, right, and we'll do another action here with control flow. Oops, that was my mistake. Wrong guy. Wrong flow. Control flow. Where are you? Oh, there it is. Okay, right. And as these guys, maybe, they do something in block 3, and then each thread could fit. Now these are multi-threaded, right? So if I want to say that this thread is done, but I'm not want to put, like a bullseye there, because that would stop the entire activity, that will be the case where you actually put just a flow final, right? So this is, right, flow final for that one. And I can reuse this one here, right? Control flow, right, control flow. So in this case, one may finish very early, the other one may finish late, but eventually, right, they both finish. So I'm not doing a synchronization in this particular example. But if I wanted to do a synchronize, in other words, don't stop until both are done. I don't, which really wouldn't make any sense, right? Because we're not doing anything afterwards anyway. But if you need to do a synchronization, you just put another one, and they look exactly the same. That's why they say fork and join, right? But now you're going to have multiple coming in and just one going out. That's the only difference. So in this case, right, we're doing both things. We're actually storing the result, right, and we're also pushing back the result right out of there. Of that, so this is going to go to 2 places. Right? So that's why I'm using a fork. There's no need to do a join, right? Activity, yeah. So we already talked about, right, the features of feature set. So the fact that it looks like a call, which technically it is, right? It is like a function call, but it's just a different way to model function calls because you're not dealing with code, right? You're dealing with things that may result in code potentially, but in SysML world, going to be a lot more than just that. So there are kind of lots and lots of kinds of actions, right? Luckily, we maybe deal with 3 or 4 of them at most. I will talk a little bit about some of these guys. You already saw call behavior, right? When I called a little pitchfork guy. So generally, call behavior, typically you do not create it from the toolbox because you should already have an activity that you're going to call. It may not be finished, like in my example, right? I called this some function, but I haven't really done all the work. But that's okay. You just create a placeholder, right, in the right under the right block, and then later on you say, okay, I have a TBD, right? I still need to complete it, but at least I have the right. I have the proxy for it, right? I can finish my diagram, and then later on I'll deal with the internals of this thing. So it's then, you just go find that activity, some function, right, drag it into the diagram as opposed to creating it from here. Because if you create it from here, then the tool is just going to prompt you. It's like, oh, which action, sorry, which activity, right? And they're looking for, yeah, because you can call an activity or state machine. These things shouldn't be here. OPEC, that's an abstract class in the meta model. This is also abstract, so I don't know why they put that there. But you could have you can call an activity, right, a sequence diagram or state machine. In this case, we're just doing activities right now. Accept event, I just showed you. I just need to talk a little bit about the other 3 cases, right? The timer is just if it's purely a timer, but I just don't like the graphics the way the tool does them. And then send signal, we're going to talk about that in a second. And just again to remind you a little bit, right? So let's just say, for example, that in addition to the timer that we're arming here, let's say that there's some other signal that could potentially interrupt this. I don't know, maybe something like the vehicle shutdown, right? So the driver started that request, and we get that command, and then it turns the vehicle off, right? I mean, could happen, right? So in that case, you would have, and that could happen anytime, anywhere, right? So in that case, maybe you'd have an accept event, right, in here, and now you basically have to say, okay, this accept event would be for a signal, right, coming from the vehicle that the driver turn the vehicle off. So we could, call that, shutdown or vehicle shutdown, right? Something like that. Okay, so what kind of an event would that be? It's not a timer for sure, right? It's going to be typically like a signal. So let's look at, when you create these event handlers, right? There's 4 possible triggers that you're going to see. And the one what we dealt with earlier was a timer, right? Pretty easy. The change one also is basically just indicating that there's a property of the block, right, of that block that you're putting this timer, that you're putting this vehicle shutdown in. And maybe in this case, we'll actually move this guy to block 3, right, just for kicks. And so the change would be that there's a change in some property of block 3. Right, so maybe some value, like for example, the change could be something like the temperature of the engine goes above, a certain degrees Fahrenheit, right? And that would trigger something like, oh, it's starting to overheat, right? That could be also a signal, but let's assume that it's just like, that you want to capture, you want to trigger it by the fact that the value, right, of some property changed. Here again, when you do that, the tool just gives you a text box, right, to kind of explain what that value change is. Ideally, they should like list the properties and say, okay, well, this is the particular property, right, that I'm tracking the value of. So they could be a lot smarter about it, but right now they're not. So you could just type something in here, what that state is, like a state of a change of state, right, with regards to that particular block. So that's what change means. And then the other one that you're going to probably use most of the time is going to be signal, right? So some asynchronous signal happened. Now, when we say signal here, when we actually look at, let's just do a search for signals. Let's see if it lets me do that. Oh, could we have to give it something? Okay, so if I give it like an A, yeah, so they're going to show me all the signals. Anything that has an A in it. Terminate clock, update clock. I have a power shutdown maybe for something else, right? Boiler signal data, cancel signal, power state pack. Yeah, I'm just like to see if there's anything realistic I have here. Otherwise, we could just create one, right? Well, actually, let's create one. It just takes a second. So we'll go in here, we'll create a signal. Say, okay, let's call it power off, right? So power off, we don't need any properties, right? We just need to know that power got turned off. So in that case, what we would do here, going back to my property sheet, trigger, right? We're going to say it is a signal. And on the specification, where the tool says, okay, tell me, right, what signal you're talking about, we'll just look for power off here. Okay, and then you would still have to give it a name. That's why the save button is enabled, because they're going to save the trigger, right? The trigger is actually an element in the database, so they want to have a name for it. So I'll just call it power off, right? Generally, I'll call it the same thing as the signal name. All right, so now we have power off. The tool will not update, by the way, the label here, right? This is like kind of under the covers, but you have a pointer, right, to an actual signal. And so now it would, should that happen, let's say block 3 is the one that's responsible for tracking, right? If we have a vehicle shutdown, because you don't want to put it on every block per se, right? That means that if this particular block 3 is interested in that signal in our BDD, what do we need to do? If you guys, anybody remember, what do we need to do to block 3 at this point to indicate that it is interested in that signal? What do we need to create?
You have to create a port from the signal to the block?
No. We need to create what? A reception for that signal. Reception, right? Because for signals, right, you create a reception. You say, as a block, I am interested in being notified when a particular signal happens, right? So logically, at this point, since we know in the activity diagram that we expect the block 3 to be responsive to that signal, right, then we would add this reception here. Let me reselect the block, right? Power off. And now we have a reception. So that, I mean, that's again to be consistent, right? You have, and that's something important that you guys need to keep track of, is when you have the activity diagrams, right? There's a lot of, because you go in fairly much in detail, right, inside the activity diagram. So you always have to think back of, like I already talked about the fact that you have when you cross boundaries, like between this case, between block 2 and block 3, that means that there is connectivity between the blocks. Why should they go back to your BDD? Do you have connectivity? Right, between, I think block 3 is actually a part of block 2, so in that case you'd be fine anyway. But just like double check right here, or you say, oh yeah, this guy is responsible for watching if the particular right event happened, if some signal went off, for example. Okay, well, would you have that? Do you have that declared in the block diagram? So when you look at the block diagram, you know that that signal is being handled. Things like that, right? And again, the tool doesn't do any of that, right? It's really up to you. But that's all right when you have, so the timer is completely local, so that's not a that's just stays within the activity. But here, I mean, because it's, you arm it here, right, then it goes off here, so there's no need to put that on the block. But here, this is something that's going to be triggered from outside, right? Maybe something else in the vehicle is tracking the fact that the ignition got turned on or off, and so that's the event that you're registering interested in. And so that, by putting it on the block as a reception, then people know, oh, okay, well, we need to notify, right? Somewhere in the block, we need to have a reception for that, and it needs to handle that, right, one way or another. And so, and right, you'd have the vehicle shutdown, and of course, then you probably just that in the vehicle shutdown, you just go off, right? But that would mean that whatever you're still executing the command at that point, you just go boom, done, right? There's really nothing else to do at this point. But at least you're dealing with it, right? Now, maybe if we turn the power off, everything stops anyway. But I mean, I'm just throwing it in as a made up example. So again, we go. I always forget flow final. No. Um, what do they call it? Initial. It's just final. But see, they keep changing. They're not consistent in their naming conventions. And I always, for whatever reason, I always have a hard time finding this stuff. Okay, so you just go final here, right? Oh yeah, it's probably just under activity final. Yeah, that would make sense. Okay. So let's see what else. So these are the four major action types. They're also directly listed in your toolbox. There's only one other one that you guys may, at least that people use on a regular basis, right? And that is calling it an operation. So if we had, I don't know, in our block diagram, sorry, do we have any? We have a reception. We have some behavior here. But let's say if we had a function, right? Let's say block 2 has a function. Actually, what we want to do is we want to cheat a little bit. Where if you want to clone a function right from one block to another, so we'll call this some function here as an operation, right? I'm just going to clone it. So now block 2 has some function as well. Then in here, this one, of course, we're inside block 2. Let's just say that maybe in the middle of this thing here. So in this case, when you say like, okay, I need to do a call, right? Call function, and you notice, well, it's not in the list here, right? Because the tool doesn't put everything there. I mean, they really should put call operation in here as well, but they don't. So it's like, how do I get to it? So what you do is when you create an action, you hold the control key down, right? And you drag the action into your diagram. And so now you get you get the same options plus, right? These are really the main ones, and you'll never use these guys. Value specification maybe once in a while, but in this case we're doing a call operation, right? I'll just put this guy in the middle for now, right? Let's say that as part of this timeout, right, we need to go maybe record that or something like that. And so when you create the call out, right, you can actually drag I could have dragged this operation in here as well. Either way, right? As a matter of fact, if we do it that way, I'll just show you, right? The tool automatically creates. It already knows what to create actually, so maybe it's a cleaner way to do it. Otherwise, if you do it from the toolbox, then you have to like actually don't double click, go onto properties, behavior, and then you have to go to call, and actually go find. See, the tool knows what you're looking for an operation. So this is an operation on block 3. No, sorry, on the block 2, right? That we call some function from here. Right. So now these two are kind of equivalent. They do exactly the same thing. So that's the only other one, right? That that you may want to use. And it's just basically, right, call that code, because it would be code at that point, right? Go do something there. And then when you're done with that, then, come in here and do a control flow, which is here, right? Now, if the operation, by the way, I didn't actually look, right? But if, yeah, so see, it notices that I think it took like, was it two input arguments and one out? So in that case, you need to feed it the two input arguments, right? Again, the tool does not complain, doesn't say anything, but it should actually be an object flow, and it should actually have two, right? Two different values being passed in, the integer and the string. Because otherwise, again, how can you call an operation if you're not passing it its inputs? I think there is a way. See, synchronize with parameters. Yeah. So if you synchronize with parameters from here, then the tool will give you the two pins, but you still have to document where they come from, where the data comes from. So action, atomic action, right? You can actually put a little bit of text there beyond the name, right? If you wanted to have some kind of longer description, which you can make visible in the diagram or not if you want to, or you could just put it in the notes. But if you put it here, I mean, yeah, you could make it visible. I think you can make notes visible as well. So it's probably no big deal either way. And call behavior, we already talked about, right? You could change it later if you want to decide you're calling something else, or if the thing you're calling like has additional parameters, right? So you added parameters, you remove parameters, or you change their type. You can call a synchronize, and the tool sometimes does the right thing and sometimes doesn't. Synchronize here is not a guarantee. What I found, and then or you can create it by just drag it and drop. Find the action the activity you're going to call, like I did, right? And when you drop it, make sure that you drop it not as a link but as a call, because it's supposed to be a call right to that activity. And then, yeah, when you create, when you do that, you can actually tell the tool to automatically do the pins. There's some bugs in that software there. So I usually don't, I just use rather than letting the tool create it automatically in this case, I just don't use that option. I simply go to features, interaction points, and I manually check that seems to always work correctly. There are selections as there's a bug in it somewhere. Yeah, there's another bug in that when the tool, when you have parameters like I had in my example there, right? Or in this case where we did the text to XML, so they copy over, so they do create the pins, right? One pin per parameter, which is great. But then if I have an input parameter, an output parameter, in other words, I have a direction on it, they don't copy the direction over, right? And there's also some other special properties they don't copy over. So I guarantee you that if we look at this one, right? Remember, they created this, right? Automatic, or not automatic. When I asked them to create it, I bet you this one is not an out parameter. I'm not saying it's a big deal, but it's a bug, right? Because the parameter says out. When you create a pin for that parameter, you should make it out as well. So I can fix it up here, right? It doesn't change your diagram. Nobody's even going to know, but it's still a bug. So calling an operation, we just did that. So we can skip over that. Accept event, right? We just covered that. Right, so you have the 4 possible kinds, right? If it's a signal, you pick, you tell it which signal it is. And then here's more some description, right? If it's a signal, if it's a time, a change, so basically what these things are. Or call trigger, that's an interesting one as well, which I forgot to mention. So call is another option. So what that means, if you select call, the tool will say, okay, show me the operation. Again, it's supposed to be an operation on the block that this thing is in, right? So in other words, if I, like here, I have this timer here on block 3. If I make this a call, right, there has to be a call that this block has itself. So it has to be one of its own calls, because but the tool again is like, it lets you do anything, right? So it lets you pick an operation on a completely different block, which doesn't make any sense. How would this block ever know that some other block got a function call made? So, but the idea behind it is interesting, because it basically says that sometimes the trigger for something is the mere fact that a function was called. Not what is put in, what does it result in, none of that. It's the mere fact that something got called, right? So in the software, you call this function, then that the mere fact that you called it becomes the trigger for something that you can then drive, right, events from in your activity diagram. So it is useful, actually, definitely useful. All right, so the timer we talked about, send signal. So we have the idea that, for on the receiving end, right, when you're looking for events, you can actually, right, you use that accept event that we just did, right? But somewhere, somehow in your activity diagrams, you also need to document, right, how does a signal get sent? Like if it's a sensor, for example, right? And so basically here I'm just showing you like the signal, right? And if I did a send signal, so the send signal again is right here, right? So in the activities that are basically responsible for generating these signal information, right, collecting the information from the sensors and then pushing it out to the rest of the system, essentially that's what you would model it. So here I just put it there to kind of know, right, that if I have a signal that says stand down and it takes two arguments, then I have to do a send signal with, in this case, two inputs, right, two input pins, right? And I would have to show where does the ID come from, the alert ID, where does the system ID come? Could be, self-generated, then it doesn't need it. But if otherwise, right, you would have to show where do the inputs come from. In that case, I think I had an example here, yeah, that we can look at. So condition, right? So when you send the signal, right, the tool again will ask you, right, what signal are you sending? So in this case, we're sending the stand down signal. And so that would be like this kind of almost like a generic example, right? That you can use for, like, for example, you have sensor data, right, that is being generated by the sensors. And so each one in this case, right, pushes out a discrete, let's say, real number value. And then uh, again, yeah, there's like things that we're not going to have time to go over in SysML, that basically, because the timings could be different, right? I mean, this could be like a 10 millisecond push out, and this could be a 20 millisecond or a 50 millisecond, something like that. So in this case, right, you basically say that, you receive the value here, but you're still waiting for this one to come in, right? So if you receive a second value on that one, that you override it, right? Because you always want to publish to the rest of the world the very latest, right, information you got. So that's, so you can mark it as an override. That's more of kind of the more advanced training classes of SysML, but at least I hope you get the general idea. And so that's the signal. And then you can actually even specify, it's an optional, right, to specify where am I sending that signal. Most of the time you just leave it off. It's a broadcast, right? So whoever's interested will get it. But if you wanted to identify it, then you can point it, where the signal is dispatched, and you can actually have it, show that you're pushing it out there. This I usually don't, unless there's a really special reason why you want to push a signal to something very specific. Unless you're like sending it to a data bus or something like that, right? And then the data bus is collecting all the signals, and then they get grouped there in like a bigger, right, signal with even more value, something like that is possible. And on the receiving end, right, you receive, so that's now this the opposite side, you receive it, right, you get the XY signal, so that you get an instance of this signal, right, which has, those two properties are in there, and then you handle it, right, for example. But that's a general pattern, right? So somewhere again, right, these signals need to get generated. Okay, I think decision and merge, we already talked about. Card condition, yeah, special else, you can always put else somewhere. I don't know if I did that here, but if it's true, false, yes, no, we can just say that. But if you have like a test condition, you can just put else. Don't know if I did that in here. So I forgot to do it here, right? Because here we say result value is greater than 0. Okay, I forgot to put something here. So as a guard condition, rather than saying, right, result, not equal, or less or equal to 0, you could say that, or you can also say just else, because that's the path, right? If none of the other paths are taken, then you take the else path. That's the rule in UML SysML. So merge node, right? Same thing, right? It's just basically helping you to make sure that you don't go with multiple connectors and then cause it to hang, essentially. So here's an example of doing both. Fork and join, right? I already talked about, so that the whole like multi-threading in code, right? It's typically the way you handle that in code is through multi-threading, but there's many other ways, right? You can handle that besides in code. And then, yeah, fork and join. Really nothing special. I mean, you could put, and conditions on there, stuff like that, but just graphically, this is going to be, this is a fork because you have one thing coming in, right? And multiple things. Again, if it's an object flow, it has to be object flow going out. And then on the way out, yeah, it could be at this point, I could also have done control flow, because it's not because you have object flow here that you necessarily have an object flow on the other side. It just happens to be that case. But at least on the input side, you have to be consistent. And then on the output side, you have to be consistent as well. But it doesn't have to be the same thing as it was on the input side anymore. And then partitions, I think we've covered those, right? So here's an example of, again, this is what the different lanes. Oh, this is the air compressor, right? Sensing pressure, passing, passing that something passes the pressure in, and as well the control, generate the torque, right? Pass it to the pump, store the air right in the tank, and then have the high pressure air go out. Pretty simple example. So I already mentioned, yeah, selectable, right? So if you do need to, let's say at some point let's say we're running out of space in one of these partitions, it's like, okay, I want to grow it now. I need to make it a little bit wider, right? You need to be able to select it. So you could just right click on the thing that's locked and just make it selectable. And now I can make it a little bit larger and probably just reselect it. I mean, relock it. If you want to do the whole thing at once, I think it's under the layout. So you make all elements selectable, right, on the selection. So that way you unfreeze. Anything that would have been graphically locked automatically gets unfrozen. And then dockable is simply that when you move these partitions, these lanes, swim lanes close to each other, right, the fact that they snap. If you don't like that, you could take that property off. But it does make the diagram look better. All right, so time is it? Yeah, we are running a little bit short on time, but I do want to have you guys go a little bit of an exercise at least. Let's try to keep it within, like, I don't know, 20 minutes or something. And there's an exercise that I pre-created all the blocks for you, so I don't have to spend time on that. So let's see, exercise 10A. Let's double check it here. Get your hands dirty, right? A little bit at least. 10A, exercise 10A, right? So the blocks are already there. So you have a system context, right? There's a surveillance system with a UI and a controller, right? And then there's an activity that you're going to call. So I pre-created the activity. I don't think there's anything in there. No, it's an empty one, but I pre-created it. And then you'll have, right, as part of the flow, you're going to call this. So that's like the basics of it, right? So this is the same picture here. So we have a validate user activity, right? So what I'd like you to do is to add one input parameter, right? Just one simple input parameter. It's called user data. It is of type string. It's a single value that we're passing in. So you're going to need to add that because it's not there right now. So add that particular parameter, and then you're going to go under system context, this guy here, and right click it, and you're going to say, right, add an activity with activity diagram. It's called logon. That's the name of the activity itself. It's called logon. And then here, right, you're going to, once you open that up again, do the same thing. So this blue partition here is like sitting in the background. So the idea is that, and you could do that, right? You can have swim lanes within swim lanes. Not that the tool sometimes doesn't make it as obvious as it should. But so we have the surveillance system, right? And it has essentially a UI and a controller. So that's what we're showing here, is that UI and controller are basically part of, right, the overall surveillance system. Most of the time I leave that background swim lane off, but as an exercise, right, it's kind of nice to know how to do that, put partitions in partitions. And then other than that, it's a very simple model, right? I'm not doing anything really fancy here with events or anything like that. I just want you to get a little, the next 20 minutes or so, get a feel for how to build up, right? It's more of an exercise of using the tool, understanding control flow versus object flow, and um, knowing the little pins, right? How to set them. So this is something that you should not manually type in, right? This is going to be your validate user. So once you add the parameter to that, right, then you're ready to use it here. So you just drag it, drop it. Remember to drop it as an invocation. So you get the little pitchfork, right, and then synchronize, or basically just go uh, to the features window, right, and you'll see your parameter here, and you check mark it, right. So the tool will then bring in the pin, and you just move it in the right location. Don't feel like you have to to do all the data typing, like string, and maybe just put a label there, right, just to save some time. But then go through here, right, to have a decision logic, right, with the true and the false, and then just let's see how far you get, right, in the next 20 minutes or so. But just at least get a feel for how to do these things. If you get stuck, let me know. So how are you guys doing? Questions? Issues?
On my side, a bit slow, but no questions yet.
Okay.
Should have probably asked this sooner, but the what I'm assuming to be parameters in stuff like the enter user data block and the read user data block, are they parameters or?
So those are actions, right? So the action bins,
That makes
right?
more sense. Okay, sure.
Yeah. So the only parameter that you need to deal with is the one in on validate user data, right? It's the only place that you add it.
Yeah.
Parameters are like a rectangle. That's also graphically an indicator. This is and it's only on activity, right? So you could only put parameters on activity. Once you're on the action level, when you have the little squares, right, you deal with action pins. And again, the tool most of the time just creates them for you, right? You saw that. You just use the right connector type and they automatically add them in for you.
Yep. Okay, thank you.
Yep. For the sake of time, I'll say probably if you make it to like relay response or something, you're probably good, you know, since we only have 30 minutes left. So don't feel like you have to go all the way to the end, as long as you get a good feel, right, for how to build a model and the tool, how the tool helps you or fights you sometimes.
Okay. Yeah, I don't know about the rest of the team, but if no one else disagrees, I think we can continue with the topics if you prefer.
It's up to you guys. I mean, I don't mind. We're not going to have a lot of time left to talk about use cases, but I could touch upon it, and or we can just continue with this. Use case is something that you could learn on your own just by going to the PDF. So either way is fine by me.
What do you think, Justin?
I just got a message from Rich. His internet has gone down,
Ouch.
so he's I mean, I'd say let's go ahead and continue on to the use cases and just get an overview of those.
Okay.
He also says he's going to try to get to a coffee shop, but if he doesn't make it, he wants to say thank you for your time on this. So
Yeah. Yeah. Definitely. It's probably because I think he said he had Comcast come out, right? And so it's like
yeah,
maybe they already tried something, and then
yeah,
so it's probably the price to pay to try to get it better is to make it worse first.
yeah.
All right. So if there's no other questions on on activity diagrams, then let's do a quick shot at use cases. Now, before I do that, I just want to show you something in the tool that if we run out of time, which we probably will, and some of you may already be aware of that. We talked a lot, I think, the last 2 days about traceability, right? Especially when it comes to requirements and how your requirements would trace to many different things. So, but we also talked about the fact that you definitely do not want to do that graphically, right? You wouldn't want to draw all your requirements on a diagram and then put all the blocks there and the activities and and build all these relationships graphically, because it's just like crazy. So how would you do that in the tool, right? In a very fast, efficient way. And so I'm just going to use something as an example here. I think from the air compressor model. Do I have any requirements in here? Oh, that's the wrong guy. That's a test. Let's look at my example models. Okay, so water distiller. Okay, so I have some requirements here for my water distiller. Okay, and let's just say that I'm going to. Do I have use cases? Yeah, I have some use cases too. Right. Okay, fine. So one of the traceabilities we talked about, right, between requirements, which in your case, right, could come from that other tool you have. And use cases would be like a use case is like a refinement of a requirement. So you may want to build relationships, right, from requirements to use cases using that refine. You could also do requirements to, I think, to the blocks, right, to the actual activities, et cetera, et cetera. But we'll just pick one as an example. So if you want to build traceability very quickly in this tool, the way to do it is to go to, I don't remember, I think it's under, is that under design? Yeah. So you're going to go under the design ribbon here. And you're going to click on package/matrix. Just open that up. Let me hide that for a second. And so now you're going to see a grid, right? The idea is that to populate the grid for what you want, right, as a source. So you're going to set, the source of the relationship or the target. What you pick as source and what you pick at target is arbitrary at this point in time, right? Eventually, when we draw the relationship, it becomes important to set the right direction. But for now, it could be anything, right? So let's just say that I have some mission requirements. I have mission statement requirements. I could pick the whole 9 yards, but let's just do, this is a smaller set. We'll just pick mission requirements. So you can just take the folder, right? And it is at the, you can either run queries, but we don't have time to show you how to do the queries. So, or just pick a folder structure, right? So I pick this folder, mission requirements. I just drop it as a source here. You could also go 3 dots and locate it in the browser, right? If that's easier. And then let's say we want to map that, we want to trace that to, in this case, this set of use cases here. So I'm doing the same thing, drag and drop. Okay. So in this case, it says all. That's why it's you know, but as you'd see, there's a lot of blanks here. There's a lot of garbage in there probably. Um, the next thing to do is to now say, okay, so on the source side, what are we looking for? We know that we want to pick up requirements. There's really not much else in there except this matrix thing, but we got to filter it down, right? We're going to tell the tool, hey, go find all the requirements. So you just, I mean, there's a big list here, which is, by the way, controlled by your perspective. That will have an impact on what you're seeing in here. But in this case, let's just go find requirements. Okay, so requirement, okay. So we have, right, residues. You're going to see, right, purification. I don't know, this is not alphabetically sorted. Not sure why they're not sorting that. Let's see, do a refresh. Okay, oh, that's better. Okay, it's kind of sorted, you know, from the kind of, you know, contrary to what you would expect, but it's fine. It's at least it's sorted. So you see things like purification, right, electrical power, etc. So you have all, you kind of populate your source side. Now let's look on the target side. And again, I'm just using the word source and target just because, you know, that's how I populate it here. So in this case, we want to look for use cases, right, and make sure that if anything else, we're not picking up any other stuff in there. So I'll just go you know, just to make it faster. Use case. Okay, boom. But there's really only 5 use cases, right, which is correct. 1, 2, 3, 4, 5. Okay, so now, so that's basically setting up, right, your matrix, your source and targets. Now that we need to think about, okay, what kind of relationship do we want, right? So from a SysML perspective, we talked about the fact that between use cases and requirements, normally you would do a refine, right? Because the use cases add more detail. So let's look for refine relationship. Here it is, right? So we're just going to do refinements, and now we have to decide, right? Is it the use case that refines the requirement, or the requirement that refines the use case? Well, logically, it's the use case, right? The use case is broader in scope, has a lot more detail to it. So it's the use case that refines, right, the requirement. So in that case, right, so the way you can read it is use case refines requirements. That means, the way I have it set it up, target to source, right? Not source to target. Because right now, if I create the relationship, it would be, because it says source to target here, right? So the way you read it then would be requirement, because that's the source, right? Because I have it as a source. Requirement refines use case. Well, that's not logically what we're trying to do, right? It's the opposite. So this is where the only time that you have to, now if I flip it around, if I were to change, make the use cases up here and requirements down here, then this would be correct, right? But now it's not. And you just, you know, you change it. Basically say, okay, right, use case refine requirement, that is correct. And now I can comment, I'm just going to just, you know, just do something silly like that, right? I'm not even looking to see, trying to make it realistic, right? But you see how quickly you can build up relationships that way, right? You don't have to do anything graphically. It's exactly, the result is exactly the same, right? You are literally creating relationships in the database exactly like you're creating relationships here, or like you're creating relationships here. It makes no difference. It's just a non-graphical way to do it, really fast, right? And if you want to now come back very quickly afterwards, right, because over time maybe you add some use cases, you add some requirements, or they change, or so you want to be able to revisit that without going through this whole rigmarole again, right, and resetting it all up. All you need to do is change, you know, I don't know why they call this a profile. It has nothing to do with UML or SysML profiles. Just like a configuration, right? And you can save this as a configuration. So on the options, what you do is you go options, profiles, right, and say save as new profile. Now this is going to go into your database, right? So for now, it will be just local to you, personal. Once you get your shared database going, right, then anybody, right, will be able to reuse these things. So I'm just going to say, you know, and because it's going to be eventually a shared environment, what I would say is, like, if you work on multiple projects, my convention is that I would say, like, you know, project name, right, whatever it is you're working on. And then in this case, I would, didn't put the O there, project name. And then I would say, in this case, right, this is use case, right? So UC, just as a shortcut, right, to REQ, right? So, or to REQ, right? Use case to requirement, something like that. You come up with some convention, well, whatever it is your convention is. So you have a consistent naming convention, because you want to look at other people's, quote profiles, right, and make use of them just as well. So come up with some nice convention there. And so now I can, I can close this thing. Now, if I reopen it right now, the tool remembers what I just did, right? But that's pure by luck, right? And so, what did I do? There's a whole bunch of these guys in here, but the one I just see, by the way, it tells you, right, how important it is to have good naming conventions, because you can have hundreds of these things in there, and then it becomes really hard to find. But yeah, if I say refresh, right, here we are. And then you could make changes, right? You just bring it back, you add a few, maybe you made a mistake. So, oh, that was wrong. Okay, delete the relationship, right? It's like doing a control delete graphically. Maybe you really wanted to pick this one. Okay, no big deal, right? And there's some graphic colors to show you which ones have been mapped, which ones have not been mapped. So that, I mean, there's more detail if you want to, because we, again, we're running short on time. I'll just point you to, for some reason, I lost my mouse pointer somehow. Let's see if I can drag this over. No, it won't let me drag it. That's annoying. So I have it on this screen. Maybe I got it back now. Okay, I got it back. Look for this one here, traceability relationship matrix, right? And it will, I mean, that has more details than what I gave you. I just gave you the basics, but it is invaluable. It's probably one of the nicest features in the tool at all, because it's so, it'll save you so much time, and it lets you easily see what's been linked, what's not been linked. You just need to be consistent, right? And come up with, here I'm just following SysML guidelines. If you make your own guidelines, that's fine, as long as you guys are consistent. But really keep that in mind, because it's a super, super useful feature. All right. If we have enough time, I'd let you play with it, but let's just look at use cases. Where are we? Here's use case diagram. So, about use case diagram, right? So the key takeaway, because I'm not going to go through all the slides, obviously, is that the idea of a use case model, a use case diagram, you want to look at the system from the perspective of the external entity, right, the whole time, as opposed to looking inside. And the reason for that is that we have all these other, ways. We have block diagrams, internal block diagrams. We have activity diagrams. We can have sequence diagrams, state machine. All these things look at the inside, right? Look at how the system does something. But we don't really have anything that basically says, rather than looking inside, right? So let's take a look at, let's play the role of the user, like the driver of the vehicle, or in your world, it's sometimes the external entity is going to be some other component, right? Some electronic component, some mechanical component, I don't know, which is fine. I mean, it doesn't change the role, and it's still like, how does that external box, whatever it is, right, interact with your entity? That's what you're trying to document. Right, so that's also out of the specification here, right? So the actor should always be outside your system. Should never have actors that represent anything else inside your system. But you obviously going to have actors to system, and vice versa. What the dialogue? That's really what you want to focus on, is what's the dialogue, and then and how the system actually does it. Well, then you're going to have very detailed activity diagrams, right, like the ones I showed you, or sequence or state machines at some point. So if we actually look a little bit deeper, so this slide deck covers both UML, SysML. You'll see some UML references there, but so graphically, it's one of the simplest diagrams to build, because it's so simple in terms of the number of elements. And so you're basically going to have the white box is just the context, so you don't even need that. I never use it, but it's kind of part of the specification. And so you have your actors, right? In this case, it's like a human being. What I would recommend is that in your world, but you're going to have cases where you have human beings, let's say, interacting with you. As actually, let's look at. I'll reuse this diagram here, right? So we have the operator, right, operating a distiller, right? This is an example of doing that. If your actors, let me pin this down, right? In the case where you have actors where you guys integrate with like some external, entity, like it's not a human being, right? It's some kind of equipment or module or something like that. What I always do is, for non-human actors, there is a CSU's rectangle, and it will still tell you that is an actor, right? So I just a convention to have. Just okay, human actors, I keep the stick figure symbol, but like here, right? But if for non-human actors, I should change it to a rectangle. And sometimes you have both, right? It could be have human interaction, non-human interaction, just as a convention. In this case, it's all human. Well, in this case, things like, see, I could have, changed card reader to non-human, right? Actually, I should have, right? Member bank, etc. I didn't do it in the screenshot. And like everything, actually, the entire thing on this side, this is an organization, right? It's a bank, it's not human, right? This is a bill stock dispenser printer in the case of an ATM. And so you just basically have the actors. We could have, by convention, again, the actors that are going to drive events into my overall system. I'll put them on the left. And then any actor that would be on the back end involved, right? But not driving events, just more like, supporting, play supporting role. In this case, like a card reader, a printer, etc. Like, just commercial off-the-shelf devices typically, right? I just put on the back end. And then, right, in this case, the bank, or the actual bank that the ATM is connected to, is not part of my system, obviously, not part of my ATM design. So that sits on the outside, right? So I put those here. Again, conventions, right? And other than that, you just have, right, use cases that you go to that basically show what is an external actor, what events is an external actor allowed to drive into your system. That's it, right? So that's basically these connection points that you have. So here I'm just going to skip over some of these slides. I'll let you guys read the detail. But it's not used for. So this is actually the key thing, right? So there's 5 questions that a good use case model will respond to, and there's one that it should not respond to. And the 5 are: who is allowed to do something to our system? When are there what are there time or timing constraints when they're allowed to do something? So the conditions, right, under which they're allowed to do it. Is there a kind of a location dependency, right? They're allowed to only do this in certain situations, certain cases. Why do they want? What do they expect back? What does that actor expect back from the system? And what is it requesting the system to do? So basically, like, here from an ATM perspective, this is like an abstract use case, because it's included, it's part of both of these use cases, right? So realistically, if you walk up to an ATM, the only case missing here is maybe you want to do deposit, right? You deposit some money, but most of the time you're going to go withdraw cash, and once in a while you do transfer money. Transfer money we just do over the web nowadays, right? But withdraw cash, we still got to walk up to that thing. So these are kind of the 2 major use cases, right? And that's it, right? That's all what the use case is. Once you start going and say, well, what are the steps of transferring money? What are the steps of withdrawing cash? You're inside that use case. It's not a separate use case. That's the biggest mistake people make with use cases. They start doing functional decomposition, like we do inside an activity diagram, right? But here the use case should be very simple. It's like, what does the user want from the system? That's it. And that is a use case. Once you're inside the use case, it's no longer a use case. Now it becomes, right, activity. Usually I just map them directly to activity diagrams. So right, so and what is the basic, what are 2 main benefits from use cases, in addition to answering these very interesting questions here, right? Who, when, where, what, why, and what? Because the rest of the other diagrams that we have in SysML do not answer that question on any of these questions. They only talk about the how, right? So it is definitely a very useful model. And the 2 main reasons why it may be useful is that if you want to like also have user guides, right? So how does somebody use, or in your case, if you're integrating with some other vehicle component of the vehicle, okay, what's the the instruction manual, right? So how do you plug this thing in? How do you test it? Right? How well, and if you run some test, what are the test results you're going to get, right? To make sure that the system works correctly. That kind of. So again, always looking at it, right, from the outside view, and then that's what you want to document as part of that use case. So, and the other reason why a lot of people use use cases is black box testing. If they're well written, you should be able to give that to a tester that doesn't know anything about something operates. They're just going to try out the device based following on your guidance to how it's supposed to work. And then they either get the right results or they don't, right? But the use case should give them enough information to do black box testing. So this one, I'm just gonna straight to the outside. I think I just talked about that, right? So don't over-engineer use cases. It's much better to over-engineer your activities and block diagrams and IBDs than it is to over-engineer use cases. graphically. Okay, we could skip over that. Yeah, this is just more the technique of how to build it. But again, it's pretty simple. Creating a SysML use case diagram. So there is, right, you just put it here. Where do you actually put it? I mean, just in a separate folder, generally, along, I would say, like along with the requirements. They should be at the system level. Use cases are by definition at the system. You should not have use cases below the system level. They don't make any sense. But you're going to have activities, right, at the subsystem, at the component level, but not use cases. So they should be somewhere in the system-related folder where you also have the system requirements, for example. Use case graphical representation. Okay, that's fine. Right, if you need to make it abstract. So abstract, the only time you use abstract use cases if you have like, pieces of behavior that would be the same. If you have like 6 or 7 use cases and they all need to, like in the case of the ATM, well, you always have to go to authentication, right? The ATM machine will want to authenticate you with your card, maybe with a thumbprint, with an iris scan. I don't know, right? But they're going to want to authenticate. So there's no reason to repeat the authentication description, right, of the behavior 6 times. You just do it once in an abstract use case and you show all the other use cases, kind of like, it's not calling it technically, but it's like reusing it, right? Including it is really, that's why it's called an include relationship. So that's what include is, right? And an extension that's a very not used very often. So I'll let you guys read through some cases of that. So we can skip over that. Discovering actors, well, who's external to the system should be fairly easy for you guys to know, right? What's inside and outside the system. You can, right, identify. I mean, this, the modeling language doesn't do that, but I like to also have like primary actors versus secondary. You saw that in my example model. Right. So, and you could even mark, right, the actor as like being primary would be anybody initiating events into your system. So things that you need to react to versus anything on the back end that you use that is, it's involved. Yes. And you want to, of course, model it as well, but it's not creating new events into your system. And you could also, on the secondary side, also say, okay, you have supporting roles or supporting devices, right, or people or organizations. So don't have to technically, but it does help people understand it. So we're not going to go through exercises. All right, let's get guidelines. Yes, also when I have, well, depending on how many use cases you have, right? You may only have, in your world, maybe only half a dozen, like, or in my ATM example, I had like 3 or 4 big use cases. But if you go to like commercial systems, right, or like, full-blown applications, you're going to have literally dozens, shouldn't have hundreds really, because there typically aren't that many real use cases, but you may have a few dozen and you can organize them, right? Basically, that's, so you also, from a naming convention, always every use case should be verb noun. If it's not verb noun, I guarantee you it's not a use case. Can't be, right? It has to be an action, some action taken by the actor. That's a use case. Right, and again, don't create use cases for anything that the system's going to take care of internally. That's why you create activities or sequences or state machines or other things. And then constraints, right, as one of the biggest, most important parts of a use case, actually, right, is to document. So again, from the perspective of, remember, you're looking at it from the perspective of the actor, right, the outside actor working with your system, with your device. Okay, so if it issues a command to you, what are the preconditions for that command to execute successfully? Right? Or the vehicle must be running, or it must be currently parked and not moving, but the engine has to be on, or whatever, right? I mean, so you're going to have a set of conditions that if they fail, if they're not true, then you already know that the actor will not be able to successfully complete. Right. Then on the post conditions is when the actor is done, executing, or the system is done, excuse me, executing the request, right, that they got from the actor. What is the state of the system? Did the state of the system change? Is it in a different condition? Is it like, its state has changed? That's considered a post condition. And for every use case, you want to think about, okay, what could possibly make it fail? What, when it, and then you have 2 cases. Everything is successful. Did the state of the system change? Yes or no? If it did, let's document that. If it failed, it could fail for a number of reasons. In each case of failure, is the system in a different state than it was at the beginning? So, you know, maybe it got stuck in the middle of doing something and now you need to go do a reset, right? So those are the kind of things you're looking for. These are the kind of things that a tester would look for, that are really super valuable for a tester to know what are the failure conditions that I need to look for. And then invariants are like, you know, does something need to be true for the, you know, for the duration of that use case? So, you know, maybe again, if the vehicle gets turned off, or you know, it stops on the road, it's no longer driving, that automatically, right, cancels what you're doing. So that could be stated as an invariant. Like an invariant basically is like something that does not vary. So you want for the whole use case, you want, right, for the whole duration of the use case, you want something to be true or false. In the case of like my simplistic ATM example, invariant would be that for the whole duration of that transaction, ATM transaction, no fraud is detected, right? So the system is not detecting any kind of fraudulent activity, for example, right? So, and then you have scenarios, right? You have the happy path, but the basic flow, the happy path, right? That would be like everything goes as you would normally expect. So the driver, you know, initiates a command and everything works beautifully. And then of course you have all the alternate paths. And the alternate path is what if, right? Or what if this, or what if that. And again, in an activity diagram, like the ones you guys just did as an exercise, this is where you use your decision logic, right? So rather than writing it all in English and text, you just create an activity diagram and you show the basic, you know, obviously you always model the basic path, and then you start thinking about, oh, what if, right? And you're really focusing on the what ifs, not down the line technical error conditions, but conditions that will flow back to the user, to the actor. So for every alternate flow, for everything that could potentially have a different dialogue, right, with the driver, for example, of the vehicle, then you want to make sure that you document that as part of the use case. But I would never do it textually. The tool lets you do it textually or with a diagram, right? I always recommend using an activity diagram. So, but yeah, this is kind of the dialogue, right? It's just a dialogue between the actor and the system has a black box, because the actor doesn't know anything about what your system does inside, but it typically shouldn't care either, as long as it gets the results, right? Results are good, it's happy. Results are not good, it's not happy, but it doesn't really care how you guys do it. So this is I'm doing it textually, which is kind of, you know, and the tool also has to come to structured scenarios. You have a PDF for that as well. You could take a look at it, but I don't recommend doing it that way. So here's some slides on how to, you know, what we talked about, like pre-post condition invariance. It's like how would you do that in the tool? So I'm just I'm showing you here the mechanics, right? There's like two ways to do it. You could do it in their big dialog box for the use case, but they also have a window, which I like the window better. We have like, you know, constraints that you could set up in there, preconditions, right, post conditions, various, right, successful post conditions, and then unsuccessful post conditions. So with a status against it, that will come out in your generated documentation. So it's pretty neat. And then, you know, basically just to finish, we have my recommendation is to basically do an activity diagram. So under each use case, like here, for example, well, actually, we probably have some here. Let me see. Shut down. Yeah. So here's the activity, right? And I think if I set it up correctly, it should drill down. Yeah. And so my recommendation for you guys is that when you build the use case model, right, in terms to illustrate what the system does, and you keep it at a very high level here, right, because you're going to have all these activities under the blocks. So most of the time, we have very simplistic examples. Most of the time, once you look at the activity diagram under the use case, your first partition, right, is going to be like the driver, the operator, whatever it is in your world, right? And then from here, most of the time, you're just going to see one partition. If you want to like start dividing it out to say, okay, this, like in your exercise model, right? We have like the system, and then maybe if there's 2 or 3 subsystems, and then you want to start showing that, it will involve subsystem 1, 2, and 3. That's fine. I mean, that, you know, I don't see any problem with that. But most of the time here, what you're going to do is make calls, right? You're going to start looking for the blocks, the activities that you've built under the block, or that you need to build, right? Because if you do it top down, you're going to start from scratch. You don't have the activities written out in the blocks, but at least you'll know, okay, I need this activity, right? I need that activity, and you just drag them in as calls. That's a common pattern for under a use case. You see an activity diagram, able to say, call this and call that. And you keep it simple. The only, and the, you know, these calls going to come back with replies, right? And then you look at the reply, says, okay, successful. All right, let the operator know, right? Yeah, everything is good. Oh, no success, something went bad. Okay. And then, you know, do they want to reach? So that whole logic, right, that I was kind of putting a little bit earlier into this here, right? So that, I mean, ideally, that kind of like dialogue between retries, all of that sits in an activity diagram on the use case side, right? And then when I actually go under the blocks, all of that's already been taken care of. The block just does its job, and it sends a reply back. I either did it or I didn't, and here's why it didn't work. But how that interacts with the end user, you can kind of push that up, right? So that the, you know, so because the interfaces to you know, machine-to-machine interface or system-to-system interfaces or human-to-system interface, those tend to change quite often, right? They get updated on a regular basis. The internals of your block shouldn't get updated all that much, so you kind of keep it cleaner and not have to deal with the, you know, with the external actor every single time, right? You let the higher level activity diagram focus just on that dialogue back and forth, right? So that it makes it for a cleaner separation. That's kind of my 2 cents on that. I think that's it, and we are out of time. So any final questions? By the way, I don't know if Rich told you guys, but as part of the training, there is like a 30-day 30-day period after this training in which you guys can contact me. You can get my contact information from Rich if you don't have it. And if you have questions, right, anything regarding to the training, right? So I can try to answer through email. If it's something that I need to show you in the tool, I have to do something, right? And we could set up like, you know, a 10-minute web session or something like that. But that's just part of the deal, essentially.
And for that purpose, in case we want to go back to the slides and recheck in case we run into something, well, the slides are there, but the partial recording of today was made by Rich, right? The one from yesterday was made by you?
No, I made both. I mean, the one.
Oh, okay.
Yeah, I think the first day, the one. Yeah. I as the organizer, I have to actually do the recordings. So yeah, I have another 3-hour recording that. But I can't. I mean, I need to wait. By the way, so let Rich know, or I can send him an email. But I need him to download, which he probably can't do because he doesn't have the internet. But as soon as he has the download done, then let them know, and then I'll publish, you know, the second recording, because I'm out of space. I mean, I have the same problem.
Okay.
Yeah. So I need to remove the first recording, and then I can publish the second one, right?
Okay, yeah, it makes sense.
Yep.
And yeah, otherwise on my side, at least, I don't have any immediate questions, but thank you very much. This was very, very helpful.
Yeah. I mean, hopefully it will help you guys out. And I know it's a bit of a fire hose treatment, right? There's a lot of information in a short period of time, but yeah.
Yeah, no, but I think we definitely came out. Oh, sorry, go ahead, Justin.
I was also just expressing gratitude, so thank you. Yes.
Yeah, you're welcome. Good luck. Have fun with the tool. Hopefully you get to use it right away and you start doing it, because if you wait for a couple of weeks, a lot of the value of what you've seen the last 3 days is going to be gone. You have to go back to the PDFs and refamiliarize yourself. But if you can start using it right away, that would be ideal. All right. Well, good luck, everyone, and have a great upcoming weekend.
Thank you.
Thank you very much, Frank. Same to you.
Yep. Bye.